So for today, the second chapter is kind of long, so I thought about breaking it up into two parts. There's like 10 different steps of it, and I think some of it, again, it kind of depends on where we all are. They go into doing things in both BaseR and tidyverse. I personally prefer doing everything in the tidyverse. There's very few things I do in BaseR, and so for today, like the slides that I prepped, I really only got through like the first half of this, mainly because I was like 11 o'clock last night and I was tired. But there's also a lot, like there's entire courses I'm just doing like data viz with ggplot and both base stuff and the controls. So we can either save that to next time, like next week, keep that up, or we can just skip it, again, up to y'all. But I prepped for just through 2.6 of the reading and writing. I think what I kind of wanted to focus on today was just making sure that everyone had Bioconductor installed and the package that goes along with the book, to make sure everyone's got everything updated, so that way when we do get into it, we can like really get going. So with that said, I can go ahead and get started. I thought my slides had pushed back to the book club, to the main page, but I don't think they got merged yet. So I'm just doing this for my local copy right now. So basically why we are all here is being able to do genomic data analysis in R. There's a lot of different ways you can process data, and there's other programs you can do this in, like Python, or like some softwares have their own individual like thing. You can just take your raw data and like put it through their particular pipeline, but we're looking to do this all within the R ecosystem to the extent possible. So I found this nice picture of just like, okay, start to finish, like how you're doing data, like what you're doing with your genomic data. So in R, we're focusing on the data analysis side of things. So after you've gotten your reads from your sequencing output, you can take those raw reads, clean them, check them, make sure everything's good, align them to wherever you need on your genome of interest, or if you're building something de novo, so just aligning it to itself to get a consensus sequence. And then from there, you can create, you can do some basic histograms and just like basic counts of what your reads are, and then you can actually go into the analysis. And so we are looking to really do all of this in R, and there is more, there are more things to do with it that I can begin to list off. And in the actual book itself, they've got like tons of different examples of what you can do with it. So if they're going through here, like all these like genomic specific analyses, and we're just touching on the very, we're only going to be touching on a couple of these, but essentially you can, it's now, there've been enough packages developed and things like that that we can do almost everything we need to do for genomic data analysis in R. And it can also connect to other things, other softwares like SQL. I think you can also like do some Python within RStudio. So there's just a lot that going in there. And another thing I want to focus on is with that. So when we think of BaseR or like the tidyverse with like ggplot and things like that, that's not necessarily what's going to allow us to do the genomic analysis. The biggest workhorse in analysis in R is a program called Bioconductor. And Bioconductor is almost just like, I think that's what to describe it as, like this giant repository of all these different packages, specifically for bioinformatic analysis. And this is really like the workhorse of what we're going to be using in this book, and just in general, using Bioconductor packages to be able to do all of this genomic and bioinformatic analysis. So if we go to the Bioconductor page, we'll see that it's, like all of the R pages, it's a very simple website, but basically all open source software allow the analysis from data from biological systems. So this is just like the main repository of all things bioinformatics in R. So go back to this page. Next one. So how many of y'all have, well, I guess first would be like does everyone have R and RStudio installed in like the most updated version of those two programs? Because I think that this is going to be obviously like what we're doing everything, and so just want to make sure everyone's on the same page. Everyone's got that installed before we keep moving forward.
Yes, I do.
Okay, great. Okay. And then do y'all have Bioconductor installed yet?
Yep.
Okay, perfect. Just wanted to make sure everyone's got it like ready to go. So, and then the package that this book uses, it's actually from GitHub. That goes along with the Computational Genomics with R. And so the package for that is through their GitHub page. So I have it in this bottom section of the code here. If we could all just get that installed as well, if it's not already installed. Daphne, do you have this one installed yet?
Yep, I do. Yep.
Perfect. All right. We'll fly through today. Okay. Yeah. All right. So if we're good to move on, like everyone's got everything installed for this. I'm guessing everyone does, but again, just making this as general as possible. So the next thing that the chapter goes into, like actually getting started with it, is also, I skipped over the computations in R. You can use R like a calculator. I think this is pretty self-explanatory. But then going into data structures. So the different types of data structures can be visualized in different ways. So I'm going to try to do this from actual memory, as opposed to just reading the book. But a vector is like shown here, one type of data where all of the data is the same type of data. And it's just individual values there. And a matrix is when you've got multiple vectors put together and they're all essentially the same type. So a vector is like one column or one row only, and a matrix is when you combine those together and you've got multiple columns and multiple rows. And the vector and the matrix are all consistent of one particular type of data. And there's what we consider to be 5 different data types. So integers are just numbers without decimal points. Numeric is actually with like decimal numbers exactly. Character values are anything with written in text. Logicals are just true, false, like booleans. And then factors are important for, they're not just characters, but like if you're just classifying categorical data. So like I have green marbles or I have blue marbles, like the factor there would be color. And then like you're actually defining the two factors as green or blue. So that would be an example of a factor. So vectors and matrices are put together of just one type of data variable. An array is similar to a matrix, but instead of it just having two-dimensional, it's actually three-dimensional. So you've got like rows and columns. So it's basically like a cube of data just in a machine readable way. And then data frames, however, are when you can put multiple different types of vectors together into one data. So like if you're looking at an Excel sheet, like that would be considered like a data frame. Like you've got different information. You can say like, okay, I have 5 green marbles, like marble color blue, like the column would be like marble color and then number and then size. Like those could be 3 different columns. And then you've got the data like blue, green, red for the color in one, and then the number that would be an integer 5, 7, 20 down there, and you can combine all those different variables with different vectors together in a data frame, because it's going to give you your full information for it. But the data frame is made up of vectors essentially. And then a list is just a way of containing all things that are related to a particular, this is not the best description of it, but a way of grouping things that are all related to one another in an uncategorized way. So if you've got something that is related to marbles, for example, you can have your data frame about the type of marbles that you have. You can have additional vectors that provide more information that don't necessarily relate to the data frame, but you can put all those together in a list that says, this is my list about marbles, and this is just like listing the things that the components that are part of it. I think that is the simplest explanation I could describe it. There is more information about constructing vectors in R, or like constructing all these components within R itself in the actual book, but I just wanted to kind of quickly highlight this as it is part of the chapter. So yeah, lots of examples here. If anyone wants to go into more detail with that. And then, yeah, so, and then I also covered data types with this, so like the numeric, logical, and character, and they also at the bottom, factors were combined with the previous section. So this is as far as I got last night, and we can definitely still keep going because we clearly have only been doing this for about 15 minutes, so I'll just keep going from the original book. But to be able to actually work in R, of course, we have to be able to import data in and to be able to save our data that we create out. So the first thing that we, one way you can read the data is just using the base R functions. And the key that you're going to be using here is the read table function. So the example that the book gave, how did they describe it? This is a the bed format. I have never actually used this format, but I guess this is used by one of the genome browsers for like mapping the references to the human reference genome or other genomes that are supported on the UCSC browser. And so this is all of the data that is annotated from that browser. And they're going to go into more of this later on, but essentially, if you run it, the file, so this is just the file path from the package here to get the actual file pulled up, and then you're going to read the file from the file path, which is like what you pulled here, and all that is just read table. The header, this statement here is that if you have like the first column, the first row of a data table sometimes will have like listed like what it is, again, like color or size or like quantity, things like that. So if there's a header there, you would put true, but if there's no header and it's just the information, that's the header is false. So you don't have that explanatory first row of what all of the different columns are. So I did this and didn't crash my computer, but it took a really long time. If you just, so we saved this table as this ENHDF. If you were to just put in ENHDF into your console and you just ran it, you're going to get all 50,000 rows. And I think I may have actually like done that. I'm looking through what mine, yeah. Looking through my old one. Yeah, so I started to do this yesterday, where I actually, if you can see in the bottom here, I actually like ran the whole thing. And it's just going to keep going and going and going and going. And this isn't really helpful for like what we need to actually do with it. And after a while, it just stopped doing that because there's 50,000 rows. So we don't need to see all of that necessarily. Like we just need to know that the data is there. So if you can check the head of this. So like this will just check the first 5 to 10. You can specify, I guess here they just automatically just the first 6, but if you just do like the head, you'll just see how the data is set up like this. You can do tail, it'll check the last ones of the data frame. But essentially, long story short, what we're looking at here is read table is actually what's going to import this data. So with large files like this, as I showed here, that there's 50,000 rows of data. And so some of these can be computationally slow for base R. And so part of the tidyverse package, which I was talking about earlier, which is what ggplot is done in, and a lot of the more common data analysis tools that have been built for R are done in the tidyverse. They have a package that's called reader. And so if you import the tidyverse, it'll be included with it. But if you haven't imported the tidyverse, you can call it separately by just pulling in the reader. So using the same data frame, this enhancer file path, we can read this instead. And the first thing that this will spit out with the read table with the reader function as opposed to the read dot table, it's just going to tell you what the type of columns are. And then instead of calling, if I called df like this data frame as opposed to the other enf data frame where it tried to pull everything, it's only going to pull the first 10 rows of this data frame. It's going to create a table. And this is a classic feature of tidy data, like how tables are done versus data frames. A table essentially is just a data frame, but it's just a little bit more like user-friendly way to read it. So you're just going to get that same information. I love the tidyverse. I try to only work in the tidyverse. I try to avoid base R when I can. I just think it's a little more intuitive to use. So then going on to writing data, you need to be able to specify, okay, I have this data frame that I now want to save, so now I can save it. So going back to the base example of write of the ENFDF, so up at the top, this data frame that we made. Here, we are going to write that data frame into a file, and we're saving it as enh.txt. We don't have row names. We don't have column names. And the type of file it's being saved as is a tab separated file. So this sep is like what you specify how the file itself is going to be saved. So essentially this is going to be saved as a tab separated file. They don't show this as an example in the text book, but again, the tidyverse and those packages have ways you can write. You can write directly, like write _CSV or write _TSV. And you can write files using a similar format, and it just will automatically save. Instead of having to write the step thing here, you can specify directly what kind of file you want to write into that. And it also is just a little bit faster. So just ways to do that. Obviously, being able to read data from data sets and being able to save the data you've come up with or the data from the data set into a separate file is important. Okay, so that's as far as I got last night. I can touch briefly on the plotting in the base graphics versus plotting in ggplot, and then we can go over some of the instructions and functions in control. And then they have a bunch of exercises for this, but I can talk for about another 5-10 minutes, but we can just kind of go through and discuss if we've got questions on like, okay, how do we, if we want to practice, like, okay, can we get these plots made? Can we do this loop? Can we do whatever? We can spend some time doing that. But that's the majority, like that's just what this chapter is. Sound good to everyone? All good. All right.
One thing I thought was interesting is I didn't realize we could actually save variables. Like in our computation, we could just like save a variable onto our computers and then load the R data back in if we need to do that. I think that's described in 2.6.1. which I thought was really interesting. I don't know if other people have used this before, but I think that will definitely be helpful for me, like
Oh,
for
yeah.
my work. I realized, yeah, I totally didn't know that we could do that, that we just could like not have to read the data back in the next time we do, like we repeat a computation, we could just like load the variable in.
Yeah. Yeah, I think that's super. I've never done this either, which is why I was like, I'm just gonna just leave this alone for now. But like, yeah, this is super cool, and it does make it, like, especially like when you're in the beginning phases of like not trying to like necessarily make it reproducible, but you're just trying to like pick it up and work on it, and then be able to put it back down, and you don't have to do anything else. You can just like literally just like save it all, and then it just reloads everything. Yeah, I think that's. Yeah, that's super convenient. It's like a shortcut, like a cheat code.
Yeah, exactly. Yeah.
Yeah.
I wonder if it's like faster than like reading all the data and have to dig more into this a little bit for. But yeah, it seems really interesting.
Yeah, thank you for mentioning that too, because I totally just glossed over that. But yeah, I'm looking forward to actually trying this out because I've never done this before. I guess the reason they don't like encourage it per se, because it is just to get like sloppy if you're like trying to do like a reproducible analysis. But again, like if you're, especially when like you're in the beginning phases and you're just trying to figure out like what you're doing, what you're not doing, and before you like clean it, I think it's fantastic. It just saves a lot of time.
Yeah.
Yeah. Deal. All right. So I'll kind of go through the different plots and the functions. So one of the advantages of using R compared to other data software frames is that everything is integrated to be able to do graphics as well as the actual like statistical analysis all in one. And I think that's really where our strength comes in. It's like it is like a data analysis and statistical software at the end of the day. That is its primary purpose, as opposed to like writing code to do computer functions. It's like you're able to actually like take data and really manipulate it and really look at it. That's like the biggest strength of R. So even base R, which again I don't use that much, but you still have the ability to do a lot in it. So for example, if you want to make a histogram of the number of counts from a normal distribution, like in this example, the code for it is very simple. It's literally one line, just the histogram of whatever your vector is. So if you wanted to do a histogram again of like the number of blue marbles you had, if you had a code that you could say like I have, you know, if you had a vector indicating how many marbles you had of the blue color, and you just like pulled, let's say you had like a bag of 100 marbles and you grabbed a handful, and each time you wanted to see how many blue marbles you pulled out, you could, and you did that experiment 50 times, you could have a call of how many times, or vector of how many times you pull a blue marble out, or how many blue marbles you pulled out, and you could plot that. And that basic plot is just the code hist and then whatever your vector is saved as, and you can and very clearly plot it. And then you can also adjust the plot by, if we go into, actually going into R itself, can y'all see the bottom of my screen all right? I'll do the example here. All right, so if I did hist, the function here, it should be able to, if we go to diagonal, so if we go into here, all of the different ways you can manipulate the plot, or they're shown here in this method. In the, if you, I'm in the help thing right now of RStudio, but like the different ways you can change it by adding the arguments after you have your the vector that you want to pull the histogram of. You just need to manipulate it. So for example, if I wanted to change the name of this histogram, I could go, what do I do it here? Yeah, main, yeah, you can just change marbles. I can do color. Color is called equals kink. And I'll go to plot. And so you can manipulate your graphs and your plots just by the arguments that are manipulated, or you can manipulate it through what the word, I can't think of the word for this right now, but essentially like you just change the argument that is in the defaults and you can just change it into what you want. So there's histograms. You can do scatter plots in the same way, and the scatter plot is the thing that's just called plot, and you can do the same type of manipulation with that. You can create box plots, all the general types of graphs you would need to be able to create data visualization of genomic data, or really any data you can already do in base R by itself. So this is just going through some examples. You can also put multiple plots together in the same thing, and or I guess the same like image. Here they're using the function par, and then the MF row is going to, like, this is actually what's going to allow it to create a matrix like we showed earlier. So you've got two of the same thing, and you've got like one graph there and one graph there, and so it's like your matrix is one row by two columns, and so you're essentially just creating that, and then you're making your plots, and you can have both plots plotted together using the par function, and that allows you to combine them together. And so you could do this for any number of size graphs. If you wanted to have 2 by 2, you would just change that to 2, and then you would have your 4 things that you wanted plotted, and you can arrange them such that they would all come out together. And then finally, saving a plot. For example, they said if you wanted to save these as a PDF, you would just need to name what you wanted to save as a PDF and the size you wanted to save. You're creating that, you're plotting it, and then closing the graphics device. So this PDF function here is like you're opening your graphics device, like, hey, we're going to create a file, and this is what the file is going to be. And then the next step is actually what's the contents of what the file is going to be. And then the dev off is, okay, I've created this file and now this is done. It's going to save it as that name, as the my graphs, my plot.pdf. And then, or you can do it where you may have your plot and then you're copying into your graphics device here as a PDF. So it's like you have your plot made and then you're telling it, hey, take this plot that I just made, put it into this graphics device. Okay, and then the dev off is, okay, now I'm done. So this is the base R way of doing things. Like I said earlier, I'm a big fan of ggplot and tidyverse. There's a different like logic system with this, and it really just allows for more like iterative building of plots and data frames. You can go directly from a data frame to building a plot. You don't have to save each individual step as something that just you can go start to finish from a data frame to a picture as opposed to having to save your data frame and then save your plot and then, or like and you can just do it all together. And the big difference with the ggplot function So you can see here, you have your data frame that you're pulling in. With ggplot, you have your data frame, and then you have to specify this layer called aesthetics. And this is actually telling it what you're mapping. So just the way that the language is written, and I think Hadley Wickham, who's the person who developed it, I want to say, I could be making this up, but I feel like I've read somewhere that he's like, yeah, had I known how this is going to work, I would have like developed the software behind it, or the language behind it differently, but you know, it is what it is. So instead of in the base R where you're just telling it, pick up from this data frame or use these vectors, you have to specify all of that in the ggplot in the aesthetic layer. And so with this, you're telling it, okay, I'm pulling from my data frame, column 1 is going to be X, and then column Y, column 2 is going to be my Y axis. And then from there, and you can build onto different data, you can build different plots. So instead of having to build a new plot for every time, if you want to combine plots together, you can do that in ggplot. So if you have this, the first thing they did here is geom point. And if you wanted to do a line, let's say if you had 2 of these that were connected, you could add the line. So that way it would connect the data points that are in column 1 and column 2 together. You could do that all in one piece of code as opposed to having to merge multiple different plots together in base R. So doing the same thing as before, you can still manipulate and change the plots. Here they created a histogram, and instead of just doing the hist, you specify each layer, each plot you're doing is a geom. So this is the geom point plot. This is the geom histogram. There'll be a geom bar. There'll be things like that. And so, and then each layer you're just specifying. So I want to change the title. So this is part of the labels. As opposed to specifying it all as a single argument as part of your base plot for R, you're doing everything as a different layer. So it just allows, in my opinion, a little bit more control. And I think it's a little bit more intuitive to read, but some people, it just kind of depends on what you like working with best. I am doing this as a very, very cursory overview of this. There is more information in the book. I'm skipping over a lot of this right now just to kind of show you the capability of what this can do. Same thing, you're having the box plot. You can create a box plot, and then you can also create multiple plots together. So instead of using that par function that was in base R, we use a function called a layer called facet grid. And here you can create different histograms. So based off different factors. So let's say for this example here, they're doing it. If you have your data 2, which was like, I have my X as column 1 and my Y is column 2. Here you're creating 2 different histograms in the same graph just by based off your columns. So you have the histogram of column X, or your column 1 is for X, and then your column Y is for 2. If you had multiple columns, you could facet through each of those columns and see how your histogram would change. And this is really useful for genomic analysis, for example. If you wanted to create this histogram, let's say for the amount of gene expression, like the number of mapped reads you had for each segment of a genome, and your genome had 3 segments, you could do a map read for each particular segment of your genome, just in this one line, essentially. So that's really useful to be able to do. And then you can, again, combine. And another way you can do it too is to be able to combine, instead of just doing it faceting by grids, you can do, instead of the par method, you can also do like a plot grid, and you can put your 2 different graphs side by side together, even if they're not directly related. So this way you're just like making the 2 together. So it's just a different way of doing it. As I was saying, the ggplot is part of the larger tidyverse system, and the tidyverse system has a bunch of different data manipulation tools and packages that really allow you to a little bit more intuitively and do more things that may not be available in base R. So this is just a very brief overview of that. Lastly, this is something that I'm actually not super comfortable with, functions and structure control. So being able to write functions, sometimes you don't have something that's already encoded into R that you need to be able to do. So you need to write a function to be able to do what you want to do with it. So for this example, they're giving, they want you to be able to return the sum of squares. And so there's no function you can just put in that already does that. So you have to be able to write something to be like, hey, this is what I'm telling it to do. So I have my function here, the function of x and y. So this is your two components of your function. So here it's going to take, you're calculating the result, and what you're telling it to do is taking the square of component x and then adding that to the square of component y and then returning what you get. And so now if you were to try this function, so you're having your two inputs of 2 and 3, you want it to do the sum of these squares, it will do so 2 squared plus 3 squared because it's your two components, and then give you the result. That would be 13. If you wanted to edit this to have x squared plus y squared plus z squared, it would do that too, and you would just have 3 components of that. And you can have it do anything. It doesn't just have to return a result. You can also have multiple lines. You can, whatever you tell your function to do, it'll do it essentially. So you not only are returning your result here, you have this result. This concatenate thing, you're essentially going to be telling it to print out what this is. And so instead of just returning the number result, you're telling it to print out, hey, this is like physically telling it to print out this is the result. So you can do if else statement if you only want, like, if one part is true, then do this, otherwise do this. And so these can be done for if else statements. So this, what are they having it do? If here, okay, this is an example. Okay, if the object is a matrix, execute the code. So here, if the CPG island length is greater than 1500, you're going to print this. Otherwise, if it's between 1500 and 700, print it as this is normal. Or if it's not, if it's less than 700, you're going to print this is short. And then so this way it's you're telling it what to print out. And if we were to run this, so I'm going to go ahead and copy this into my bar sheet, my console. Tell me I can open that. Give me a moment, y'all. Okay, we're gonna not do that. This is something I should have prepped beforehand, so I apologize. But essentially, if you have a table and you've got in this table, it would have a column, so a vector that would be like if, and the vector would be the CPG length, and then you would have the different rows for the different size for, I guess, whatever particular part of that genome. Thank you. Thank you, Daphne.
Yeah, it seems like you need to do the system.file.
Oh, got it. Okay. And then I can do it.
You should be able to. All right, you should, and then you can do read.table and then replace the string with enhancer file path.
Okay, so if I have the read.table, okay, and then I'm doing the enhancer file path.
Yeah,
exactly.
Okay. Replace the string with the enhancer file path.
Okay.
Oh, so I think it's just,
Do you have it pulled up? Is it working for you?
yeah, let me.
Yeah, I'll stop sharing if you want to share it instead.
Okay, yeah. Um, you all see my screen?
Yeah.
I think, okay, let's try this out. So,
Oh, I see what you're saying. Okay.
no, it still didn't work.
Okay.
Are you able to get it to work?
I'm working on it. Okay, I actually, I guess I had loaded it in earlier, which could be why it didn't. Yeah, let me see if I can, because I have it, it's already in my environment here locally, so I didn't had set it up earlier. Okay, I think I got it to work. So I went ahead and I'm gonna share my screen. All right. So I got so I had previously here, I had already had it in my environment, so I hadn't saved it from last night. I already had the cpgi.df. I think there was an example earlier in one of the chapters where you actually, I think it's in the reading and writing that I took it out on the thing, but yeah, I had this already. Oh, it's system file. I think that's what we had to do. That's what we did earlier. Yeah. I don't know, but I got this in earlier. And I already had loaded it as the read table. So this is just going back to what we've done earlier, or what was done earlier in here. So if I go and I run run it as this, so my input for this is the row, like that particular matrix subsets of all of that here, and it's returning this is short. So this is the 1 for 10 is looking at the 10th row of that data frame. That's what this 10,0 is. So it's like the 10th, yeah, the 10th row essentially. And if you wanted to look at one particular spot, or if you're looking at a row versus column, that just you would adjust how that is framed. So the 100th spot on here, I wonder if it's showing that up. So I had 10 here, so 23, is that what 24 is? Versus 100, that's 116. Back to what that function is. Oh yeah, okay, so row 3 minus row 2 plus 1, so that the difference between those values, if we go to 10, and just pull the calculator real quick. So here we had row 3, 539222. Minus 538222. That gives us 1000. And so I thought this was supposed to, for this, I did this correctly. So the 539222 minus 538. Oh, that was 13, not 10. Sorry. That's why. 348469 minus 348 244 225. So since here the essentially if it's greater than 1500, we're going to say it's large. If it's between 1500 and 700, it's normal. Otherwise, because instead of having to say if else if less than 700, because there's only 3 options it can be. You've got option 1 is your if, option 2 essentially is the else if, and then option 3 is everything else. It's not one of these two, so we just have else. And so this is short. And so since 225 is less than 700, it's going to return this is short. And that's what we got. And if we were to do the same thing for 100, we can do that too. If we were to do that calculation, it would come back between 700 and 1500. So that's why it's coming out as this is normal. So the way with seeing how it's this data frame, this is telling us it's just pulling row 10. If we couldn't do this, if, for example, if I wanted to do this as 100/1, I'm going to get an error because 100 looking at 100 comma 1, that is looking at row 100 column 1, and that's just going to give you the CHR20. Like that doesn't allow us to do our calculation. And if it, for example, if I were to also do this as comma/100, I'm going to get another error too because I can't. There's that column doesn't exist. So writing it as the 100 comma 1, that's telling it I'm looking at row 100 and I'm not looking at the column. And if I were to do 5, you'd be able to do the same thing. And so you can have it go through. If you wanted to look at one particular row by row, this is how you would do that. But sometimes we don't want to look at every single row. We want to be able to do it for everything. We want to be able to see, okay, how many of all of those can I get the count of how many are normal, how many are large, how many are small. And so we can have a loop that does this. And so you could do, for I in how many number of repetitions you want to do. And then you can concatenate this cat and be like you're printing. And then you're printing the number of iterations it's gone through. So this would be like, this is iteration 1, this is iteration 2, this is iteration 3, and it's going to go through and print it out. This is just an example. So this it's going to calculate, so in calculating the first the CBG islands, so the first 100 islands in the data frame. So if we were to start this loop, here we are having to create an empty vector that the results are going to be stored in. And so like I was talking about the example, if you wanted to calculate the length of it, like of all of them for the first ones of the CPG islands, instead of having it say like this is normal, this is not, like we're just like physically getting the calculated result, you could write the loop for this. So if I were to run this, so we're gonna create this vector real quick, and then we're gonna start this loop. So for the I in 1 to 100, so we're going through the first 100 rows of this data frame. We're calculating the length, and this, so the length here is being calculated. This I is like that iteration that we're going through. So this is going to do this for every single row. So the first time it's going to be row 1, column 3 minus row 1, column 2 plus 1. So the exact same thing as we did in this formula. It's just you're having row 3, row 2, comma 1. So instead of just doing this for individually doing this, we're having to iterate and go through it every single time, like every single row by row. And so that's what this I is here, because you're doing row 1, column 3, row 1, column 2, row 10, column 1, 3, row 10, column 2. And then you're going to get a list that's going to continue to just grow. So we're going to go ahead and copy this in. All right, so I've got that loop in there. And then I can then check the head of the result. And it's going to tell me that if I were to just do result by itself, this would tell me, this is going to give me all of the lengths of everything that of all those CPG islands for every single one. So when we ran this calculation, it just went ahead and did all of this and then put it into the result column. So this would be our final output. And this is, I feel like a whole nother, you could just do an entire thing just on this. So instead of writing for loops, there's other functions that can be used. So like in base R, it's the apply family of functions. In the tidyverse, it is the per family. So if we wanted to do this, I don't know the best way to do this. I apologize, y'all. I should have had this prepped earlier. I didn't know we should go through the beginning so quickly. So the apply family, the way that it works, you're telling it to go through, you're applying in this matrix the function where you're just summarizing all of the sum of all the columns together, and that's going to be the result. And so you're just having it go through and do this row by row by row. So instead of having to write a loop that says like for I, all of the rows that you have, like this can be used to do it for any number of rows. You don't have to specify how many rows it's going to do it through. It's just going to do it to that entire data frame or this entire matrix. So for here, you'd be applying to the matrix your function, which your function here is the sum of everything here. And then that's going to give you the result of these, the sum of all the columns. And so you're just going through row by row and doing that. But instead of having to specify like specifically for the rows in this frame that I'm doing, you're doing it just indiscriminately to the entire matrix. And you can do the same thing if you had the columns you want to do that to. You would just need to if you wanted to go through and have it summarize, yeah, you're just doing the same thing. And you're just, instead of having it go by row, you're having it go by columns. You're just summing each column and you're doing this indiscriminate. consistently across the board. So instead of, yeah. So this argument here is when you're doing the apply. In the first argument up top, this is 1. This means you're applying it to the rows. When you change this here, this 2 means you're applying the argument to the columns to sum it here. So again, in base R, that's how you would do that. And you can do this not just for matrices, you can also do this for lists or vectors just by changing the apply family. So this L apply means you're going to just do it to an entire list or a vector. The M apply, it can do it to not just one list or vector, it does it to like multiple list or vectors. So here you would be summing the 2 different vectors together. So that's why you're doing the M apply as opposed to just apply, because you've got 2 different particular ones. Sorry, yeah, good to see you, Daphne. We'll see you next week. We're basically done with this. I don't know if y'all have any more time. I can keep going with this, or I can just let it be. Any other questions so far? I feel like this in and of itself is like something that I know I'll need to sit down with and really look at it some more, since I struggle with these concepts, but I do just want to like introduce it quickly. You can I guess have it do not, you can have it like go multiple times over. So you can have it sum this, and then you can have it like resum just the 2 of those together, and then you could get like one separate sum or core. Vectorizing this. Using the plus, if they're vectors for this, you can also, if it's like 2 of the same thing, you can just use the plus instead of doing the M apply. Yeah, so this was a very, very quick overview, and like I said, I apologize for not having this more prepped beforehand. I didn't expect, I was thinking we were gonna have to like break this up into multiple sessions, so I didn't finish prepping it. But are there any questions so far, like anything that we want to spend more time looking at, or is it just something that's kind of just going to be some self-study just to kind of cement the idea of what it is in your head? I know I gave this a super quick overview, and I'll go back and I'll try to update the notes that I had done along with it to try to reflect some of these things that we talked about today. Are we good? Good deal. All right, well, I guess I'll talk to y'all next week. It's Federico, you will have the presentation for next week.
Yeah.
Okay. All right, sounds good. All right, well, I guess I will talk to y'all next week then. All right,
Thank you.
have a good weekend. Yeah, all right, bye.